Hello, this is the Code Critics. In this episode, we're going to get a better understanding of iterators in Python. First, let us clarify the differences between iterables, iterators, generators, and sequences. Here, a simplified view of the class hierarchy. Iterables are at the top, and any object that has an iter method is an iterable. Objects with an iter method can be placed in a for loop. All data structures in Python, including lists, are iterable and therefore can be iterated over. The iter method returns an iterator. Every iterator has two methods: iter again, which usually returns the iterator itself, and next, which returns the next element of the iterator. We can get the iterator for a list by calling the iter__iter___ method, and then can iterate step by step over the elements in the list by calling __next__. Since the double underscore syntax of the special __iter__ and __next__ methods is rather ugly, Python has the convenience methods iter and next without the underscores. Under the hood, these functions simply call the corresponding special methods with their underscore names. Generators and sequences are both iterators, but offer additional methods. In the case of generators, the additional methods are send and throw that are used in the context of coroutines. In the case of sequences, we have the additional len and getItem methods. Lists, for instance, are iterables, iterators, and sequences, since we can call len for a list and can pick a specific element from the list using the bracket notation, which is just syntactic sugar for calling getItem. In the following toy example, we are going to implement our own iterator that behaves similar to Python's range function, but starts from 1 instead of 0. The constructor init of the class takes the maximum number n of the range and initializes a counter variable I. For an iterator, we now need to implement the two methods iter and next. The iter method is trivial and just returns the class object itself. The next method increments the counter variable and returns it. If the counter variable I is greater than the range n, we raise a stop iteration. Now we can construct a myRange object and can call next until the iterator is exhausted and the stop iteration exception is raised. If the iterator is called in a for loop, the stop iteration exception terminates the iteration without showing an error message. So myRange works the same as Python's range function, but Python's range is actually a sequence, since we can get the length of a range and pick specific elements from the range. We can easily support that as well by implementing the getItem and the len methods that are required for sequence objects. Len simply returns the maximum number n of our range. GetItem takes an index and returns the value of a sequence at that index position. So for 0, it returns 1 in our case, since our range starts with 1. Therefore, we simply return the index plus 1. And now we can call len for myRange as well and retrieve elements from myRange at a given index position. Real-world situations where you have to implement your own iterator class are comparatively rare, but a common case is readers for specific file formats. As an example, we will implement a reader for files in Fasta format. Fasta is a format for storing genomic sequences. Every sequence starts with a descriptor line indicated by a semicolon or a greater than sign, followed by multiple lines of sequence data. in this example, amino acid sequences. The Fasta reader class shown here takes a file path and opens the corresponding file in the constructor. Note that open returns an iterator over all lines of the file. As before, the iter method simply returns the iterator class object itself. The next method is more interesting. First, we implement a short lambda function to read a line from the file and strip all white spaces. We use it to read the header line first. To read all the subsequent lines that contain the sequence data, we take advantage of a special feature of the iter function to look for a so-called sentinel value. Here, iter calls the next line function until the next line returns an empty string. This is our sentinel value. We then simply use join to join all the sequence lines that iter returns. Note that we don't have to raise a stop iteration exception here. The iterator returned by the open function does that for us when all lines of the file are read. Also note that we have two nested iterators here. The iterator returned by open and the iterator that reads the sequence lines. While this implementation works, it is incomplete, since it does not close the file. We could open and close the file externally and pass on a file handle instead of a file path. But it is more elegant and easy to implement a context handler instead. How exactly a context handler works is beyond this video, but in short, it allows to manage resources such as files and is invoked using the with as syntax. We only need to implement an enter and an exit method. The enter method returns the class object itself. We could open the file here as well. And the exit method closes the file. And that's it. Now we have a lazy reader for our Fasta files with resource management. Many functions in Python return iterators. Here we will look at some examples for the most common ones. Let's start with enumerate. Enumerate takes any iterable, and strings are iterables, and adds an index to the elements of the iterable. Iterators are lazy and don't do anything until next is called. So if we call enumerate for a string, we get back the address of the iterate object, but nothing else. We can assign the iterator to a variable and call next on it to get the first character of the string and its index. But typically, we would call enumerate in a loop, which internally calls next on the iterator until the stop iteration exception is raised. Reversed is another common iterator. As before, nothing happens if we just call reverse. It needs to be part of a loop or used by a function that accepts and executes an iterable or iterator. The list function does that, for instance. So we can get a list with the reversed elements of the string by passing reversed to the list function. When working with strings, we usually want a string as reversed output and not a list. Similarly to the list function, the join method also accepts an iterable as input, and we can reverse our string this way. Enumerate and reversed accept only a single iterable as parameter. The zip function, on the other hand, accepts multiple iterables, which allows for some neat tricks. Here we create an iterator over a list of numbers and pass this iterator twice to zip to convert the list of numbers to a sequence of paired numbers. Zip itself returns an iterator, and here we use the tuple function instead of the list function to materialize the iterator as a tuple. Two other common iterator functions are map and filter. Map maps a function on the elements of an iterator, and in this example we use it to convert integers to strings. Filter allows us to filter elements from an iterator. For instance, filtering for all numbers greater than 2. Iterators can be chained. Here we first filter for integers greater than 2 and then convert them to strings. Note that the pipeline of chained iterators remains lazy. Each number is individually first filtered and then converted. As a consequence, iterator pipelines can result in very efficient and compact code that only processes what is necessary. One disadvantage of longer iterator pipelines is that the nesting syntax leads to code that is difficult to read. Data flow libraries for iterator chaining, such as nutsflow, avoid this. To summarize, iterators are lazy. They process data bit by bit and only when next is called. This enables the processing of data too big to fit in memory and also allows the construction of efficient data processing pipelines by chaining of iterators. Iterators are simply classes that have an iter and a next method. They can be infinite, such as enumerate for instance, but usually raise a stop iteration exception to terminate the iteration at some point. Since iterators only have a next method, they can only go forward. You cannot go backward or reset an iterator, but you can always create a new one by calling iter. Without a surrounding loop, list comprehension or sync function that accepts an iterator, nothing is happening. Something has to call next to actually run an iterator. All generators are iterators, but not vice versa. Generators have extra functionality to implement coroutines, for instance. Similarly, all sequences, such as lists or tuples, are iterators. But sequences have extra functionality, such as getting the length of a sequence or retrieving elements at specific index positions. And that's it. Thank you for listening. You will find the links in the description and please subscribe or like.